Our sun is a star, a massive ball of burning gas that provides the energy necessary for life on Earth. A star among billions in the Milky Way galaxy, each one potentially hosting its own system of planets. And the Milky Way is just one of billions of galaxies in the universe, each containing countless stars and possibly even more planets. For centuries, humans wondered if our sun was unique, if it was the only star with planets orbiting around it. Did other stars have planets too? This question intrigued astronomers and dreamers alike. Could any of those planets be like Earth? Could they support life as we know it? The first confirmed discovery of an exoplanet, a planet orbiting another star, came in 1995. This was a groundbreaking moment in astronomy. This planet, 51 Pegasi b, was a gas giant like Jupiter, but it orbited its star incredibly close. This discovery shocked astronomers and challenged existing theories. It challenged our understanding of planetary systems and opened up new possibilities for what kinds of planets could exist. Since then, astronomers have found thousands of exoplanets, each one unique and fascinating in its own way. These discoveries show us that planets are common, not just rare anomalies in the vastness of space. They're not the exception, but the rule. Planets are everywhere, in every corner of the universe. The universe is teeming with worlds, each one a potential home for life. The search for exoplanets is a journey of exploration, a quest to understand our place in the cosmos. It's a quest to understand the diversity of worlds that exist beyond our own solar system, to see how they compare to our own. And it's a search for another Earth, a planet that could potentially harbor life, a place where we might one day find signs of life beyond our own world. Finding exoplanets is a challenge. These distant worlds are not easy to spot. They are tiny, faint objects next to the bright glare of their host stars. The light from these stars can easily overshadow the planets orbiting them. Imagine trying to see a firefly next to a spotlight. The contrast makes it nearly impossible to detect the smaller light. But astronomers have developed clever methods to detect these hidden worlds. Through innovation and technology, they have found ways to overcome these challenges. One method is the transit method. This technique involves observing the light from a star over time. When a planet passes in front of its star, from our perspective, it causes a slight dip in the star's brightness. This dip is a telltale sign of a planet. We can't see the planet directly, but we can see its shadow. This shadow gives us crucial information about the planet's size and orbit. Another method is the radial velocity method. This technique measures the star's motion. A star and its planets orbit a common center of mass. This shared center causes the star to wobble slightly. As the star wobbles slightly due to the gravitational pull of its planets, we can detect tiny shifts in its light. These shifts are like fingerprints of the planets. These shifts tell us about the presence and mass of the planets. By analyzing the light spectrum, astronomers can determine the planet's characteristics. These methods have allowed us to find a wide variety of exoplanets. From gas giants to rocky worlds, the diversity is astounding. Each new discovery adds to our understanding of planetary systems and the conditions that might lead to life. The search for exoplanets continues to expand our knowledge of the universe. Not all exoplanets are created equal. Each one is unique, with its own set of characteristics and conditions. Some are scorching hot gas giants with thick atmospheres composed mostly of hydrogen and helium, while others are icy, barren worlds far from their stars where temperatures plummet to hundreds of degrees below freezing. But some planets might be just right for life as we know it. These are the planets that capture our imagination and fuel our quest for discovery. These planets reside in what astronomers call the habitable zone, also known as the Goldilocks zone. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, but just right. Liquid water is essential for life as we know it. It is the medium in which the chemistry of life takes place. It acts as a solvent for biological processes and plays a crucial role in the chemistry of life. Without liquid water, life as we understand it would not be possible. Planets in the habitable zone are not guaranteed to have life. There are many other factors that come into play, such as the planet's atmosphere and geological activity, but they have the potential. This potential makes them prime targets for further study and exploration. Finding a planet in the habitable zone is a major step in the search for life beyond Earth. It brings us closer to answering the age-old question. The search for life in the universe is driven by the profound question, are we alone? This question has fascinated humanity for centuries. Finding another planet with life would be one of the most significant discoveries in human history. It would change our understanding of our place in the universe and open up new possibilities for exploration and discovery. The exoplanets we've discovered are incredibly diverse. Some are gas giants larger than Jupiter, while others are rocky planets smaller than Earth. Some orbit their stars in hours, while others take centuries. We found hot Jupiters, gas giants that orbit their stars incredibly close, and super-Earths, rocky planets larger than Earth but smaller than Neptune. We've even found planets orbiting pulsars, the rapidly rotating remnants of dead stars. This diversity tells us that our solar system is not the only way planetary systems can form and evolve. It challenges our assumptions about what makes a planet and expands our understanding of the possibilities for worlds beyond our own.